Hey all, so today we are going to talk about some of the numerical problems on velocity and displacement and velocity. So let us start with it. So, but before starting with the problems, we will talk about some of the formulas related to the previous lectures to recall them. So, first formula which we used is related to average velocity. So what is average velocity? So average velocity is defined as simple formula is if you are representing it by v, so it is a vector, so it is x at t plus delta t minus xt divided by t plus delta t minus which is delta t, or which is also written as if you are taking this as delta x divided by delta t, right? This is called average velocity. Now the second formula is instantaneous velocity. Remember all the quantities here are vectors except time. So this is displacement, this is a vector. So this instantaneous velocity is defined as v dash, if you are representing it by v dash. It is rate of change of displacement with respect to time, right? So dx by dt. So you can see now one important thing is that the important thing is that instantaneous velocity describes correct, basically provides correct information about any motion at any moment of time, whereas average velocity provides an approximate information, complete information, provides complete information, right? Complete information about motion of the particle, whereas average velocity provides approximate information about motion. So that's the difference. So if it is asked find the correct velocity, so it is the instantaneous velocity, which basically describes the motion in a correct way. Now there will be one case in which this average velocity will be same as the instantaneous velocity, that is uniform motion. Uniform motion. Average velocity is same as instantaneous. Instantaneous velocity. So in that case only the average velocity will provide a correct information about the motion, right? Similarly, this average acceleration provide information. It is defined as A is v at t plus delta t minus v at t divided by delta t. So this is, if you write it delta v by delta t as this change. So this is what we call the average velocity acceleration. Now what is instantaneous acceleration? Instantaneous acceleration E dash is defined as time rate of change of velocity dv by dt, right? Now the same rule which is discussed right here applies to acceleration also. So you see the instantaneous acceleration which provides the correct information, about the motion, and average acceleration only provides the approximate information, right? So this is all in the formulas which we derived in the previous lectures. Now let us go to the simple problem of NCERT. The problem number 1, which we are starting with, is here. So let us consider that 2 boys are there. They are starting from the school at certain time t. So the question is here: 2 students are there. The students are starting from the school to home, right? Now the graph of their motion is given right here. Let us so one is this. One boy is represented by, its path is represented by B, its home is P, another is Q, and it is by B. So one boy is named as A, another is named as B. Now they are moving, this is the time scale T, and this is their homes, Q and P, and this is the origin of the school. This is the origin point to school. Now, why I am discussing this problem? Because this problem will help you understand how to tackle the graphs of position time graph, right? So this position time graph here, it is representing position is time. Now let us first question. The first question can be whose home is farther from the school. So if you look at it very carefully, now what I am saying that it is the graph, right? Right? So this is the graph. If you this is time t1. If you are taking a t1, t2, right? Now if you look at it carefully, then you will see that this student for A, this boy A starts earlier, right? It is starts as time t equals to 2. So A, the first is A start earlier. Earlier than B, right? This is one thing. And then, so we will try to find out all the information from the graph. Now, A starts earlier than B because it starts at time t equals to 0, whereas B starts at certain time t, right? Let us take it capital T, right? So B starts at t, A starts at 0. So this is A, this is B, right? Now, whose home is nearer? So obviously, A's home is nearer, it is P. So this is the distance. So this is the distance. This is PO. That is nearer. This is smaller. So A home is nearer, right, than B. Now the another question is that who reaches earlier? Who reaches earlier at home? Now if you look at it very carefully, B, who starts at later, its slope is higher, right? Its slope is here, not this one. This is slope. Now you can see the slope is higher in one case than the other case, right? So higher the slope, it means that in a smaller time variation, you take any 2 points, a smaller time variation, larger shift in displacement is observed. right? So this is the case here, right? Tan theta equals to this divided by this. So this is larger, as angle is larger, theta is directly, tan is directly proportional to angles. So this with a theta, so it is this divided by this. So it is directly proportional to x by t, right? So if it is higher, it means that x is higher with respect to compared to t, or slope is higher. X by t is higher. It means that the B travels larger distance in shorter time, right? So higher slope of graph segment B than of A, right? So it means that B will take lesser time. B will take lesser time. As you can see, B is taking the T1 only. E starts at T and T1 is T1. So this is the time he is taking. Lesser time than T1. And so B is taking how much time? It is T minus T. Sorry, T1 minus T. And A is taking, it is T2 minus 0. This is T2. So you see, T1 minus T is this much, and whereas T2 minus 0 is this much, this complete time. So A takes larger time to reach home than B, right? And who reaches earlier? Obviously, B reaches earlier because he is accelerating faster. Both are accelerating, but one has a larger acceleration, another has the lesser acceleration, right? So B reaches earlier than A. If these 2 points were overlapping, then they would have been reaching at the same time, right? So this is all we have in this problem. Now let me check whether there is another section also. Yeah, the one question, the last question is, how many times they are overtaking each other? So only one time. This is there. So only one time they are overtaking each other. One time. So this is the problem number 2, right? So this is one simple question which we just discussed. Means how to solve the graphical problem. Let it be below this position time, right? Now let us go to another problem. Another problem is regarding the displacement and average velocity and average and speed. The first question is, the question is there. This is question number 2. It says that a person is starting from home to the market. .5 kilometer away with a speed of 5 kilometers per hour. Right? Now, when he reaches market, this market is closed. So he starts returning back immediately. He starts walking back immediately. Right? Immediately. Immediately, right? Walking back immediately towards home. With an average speed of 7.5 km per hour. So the question first is find average speed and average velocity. Find speed and average velocity in first 30 minutes. First 30 minutes. And then second is find in same thing, speed and average velocity in first 50 minutes. Now this is one fine example of displacement and distance, velocity and speed, right? So this and find the speed and average velocity in 40 minutes, right? So we will go to the 30 minute, 50 minute and 40 minute one by one. So let us calculate the first one. So as the distance traveled by it, let us start, this is his home and this is the market, right? He is moving in positive x direction, which is right, positive x direction, right, 0, this is positive x direction, right, and this is 2.5 km and moving with a speed of 5 km per hour and returning back with a speed of 7.5 km per hour, right? Now if you see it, so what is the average speed when he is moving in the forward direction? It is, so time taken, it is 2.5 time t1 is distance divided by speed. So it is 2.5 divided by 5, with both are in kilometer. So it is half hour or 30 minutes, right? Now let us go to the back. So this is the first 30 minutes. So in first 30 minutes only the person reaches up to the market only. So it means that what is the average speed? Average speed average velocity first, then mod of it. Average velocity will be, as it is moving in the positive x direction, it is distance divided by time, 1 by 2. So 5 km per hour is the average speed, average velocity in I cap direction or a plus x direction. Now average velocity, average speed will also be same. It is distance divided by time, 0.5 or 5 km per hour, right? As this is speed and scalar quantity, so no direction. Now let us go to the second part. Now in the second part, please note it down. So in the second part, let us discuss it here. So in the second part, what it does is returning back, right? So in the first, so after he takes 30 minutes to reach here. Now how much time he takes from this point, the market? You take here as A and this is B. So B to A. Now this is A to B. And then B to A. So B to A is from B to A. B to A. Time T2 is nothing but average, distance divided by average speed. Now distance is same, divided by average speed is 10.5, so it gives you 1 upon 3 or 20 minutes, right? 1.3 hour or 20 minutes, right? Now, so total time is how much? Total time is T1 plus T2. It is 30 plus 20 is 50 minutes, which can be written as 5 by 6 hour, right? This is what we have. Just divided by 50 divided by 60 minutes multiplied by 1 hour, which is 5 by 6. So this is total time. Now average velocity. Now here it comes the important role of displacement. You see, when he goes from A to B, the displacement is plus 2.5 kilometer. So 2.5 kilometer in I cap direction, if I am taking I cap. Now he is returning from B to A. So he again came to the same point from where he started. So it means that its total displacement is 0. 2.5 minus 2.5 divided by time, 5 by 6. So this is 0. So it means that average velocity is 0. Right? So you took the algebraic sum. Keeping in mind with the time. Now what is the average speed? But is the average speed also 0? No. So now let us take the modulus of this. So 2.5. So modulus average distance this 2.5 plus distance this. Sorry. So here 2.5 plus 2.5 divided by this time 5 by 6. So it is 5 divided by 5 by 6. So average speed will be 6 km per hour. Just simply multiply, right? You see, so average velocity is 0 in this case and average speed is 6 km per hour. Now let us go to this last part, the third one. So in third one, if you see, it's saying that how much is the time, it has how much is the average speed and velocity in first 40 minutes. So let us go to third. And first, how much, you know that in first 30 minutes, it travels 2.5 kilometer. Now in the next 10 minutes, how much he will travel? So time multiplied by speed. So distance, you take as x3 is 10 minutes, which is 1 by 6 hour, right? Multiplied by 7.5 kilometer per hour. So see, this is 5, this is 4. So 5 by 4, right? Or 5 by 4 or 1.25. So distance traveled is what we just calculated in last 10 minutes will be 1 by 6 multiplied by the average the speed, which is 7.5. So it is 5 by 4, which is 1.25. So distance is 1.25 kilometers. Total distance is how much? So total distance will be 1.5. Sorry, 2.5 km plus 1.25 kilometer. So remember that this is distance, not the displacement. So it will be 3.75 kilometer. Now what is the displacement? Displacement will be 2.5 in the positive x direction, 1.25 in the negative x direction. So 2.5 I cap minus 1.25 I cap, which is giving you 1.25 I cap as the total displacement, right? Now let us calculate the average speed and average velocity. So average speed is what? So average speed will be simply distance divided by time. Distance is 3.7. So 3.75 kilometer divided by 40 minutes, which is 4 by 6 or 2 by 3 kilometer. 4 by 6 or 2 by 3 hour. So 3.75, which is divided by 2 by 3. Now just reverse it, giving you 3 by 2. Now what is 3.75? It is nothing but 15 by 4 multiplied by 3 by 2. So just multiply it, 15 3 like 45 divided by 8. So this is your average speed, kilometer per hour. And what is average velocity? Average velocity will be displacement divided by the time. So displacement is 1.25 divided by time is how much? It is 3 by 4, 2 by 3. So it is 1.25 multiplied by 3 by 2. So 1.25 is how much? It is nothing but just simplify it. So if you can simplify it, you will get it 15 by 8. Right? So it is so 5 by 4. It is 5 by 4 multiplied by 3 by 2, giving you 15 by 8. So this is kilometer per hour. So you can see how we can solve. This is how we calculate that average displacement, distance, and speed and velocity. So hope this example would have made your concept clear regarding the displacement, distance, velocity, and speed and velocity. Now we will see some of the more problems related to the acceleration in the upcoming lectures. Please do watch, like, and subscribe, and comment if any concern regarding any other problems there.